everyone. I think it is still morning, right? Yeah. Hi, my name is Kanchana Wickremasinghe, VP and GM for Choreo Business Unit. I operate out of WSO2's Australia office in Melbourne. It is such a privilege to be here. This is my third WSO2 conference, and most importantly, this happened to be here with the 20th anniversary of WSO2, which you guys heard a lot about. But without further ado, let me get started. So I'm going to be talking about a little bit about Choreo for those of you who haven't heard or learned about Choreo before I go into all the updates. If you happen to be in the Barcelona Con or the US Con the last year, some of this may be a little bit repeating, so apologies in advance for that. But let me go over what Choreo is. So we call Choreo the internal developer platform, that platform that actually your teams will be using internally. But what does it really do for you? So if you look at the whole software development lifecycle, you start from getting an idea, designing it, and then deploying it and managing it, etc. So this whole thing, the SDLC in short, as an acronym, is from coding to taking to production and then managing it in production grade, right? I know there is a lot of vibe about vibe coding and deploying it. They are really good for doing simple things, but in an enterprise, which all of you all are, you have to take that and manage it in an enterprise way, which day 1, day 2, day 3 changes and managing it more effectively, right? So bringing these two together, the business value that your developers create from the business requirements, etc., taking it and managing it in production at production grade is what Choreo brings together, or glue together rather. So what does this mean in terms of who builds and who takes care of it? Two big personas in Choreo, the platform engineers, right? In my view, though, platform engineers is not something really new. Platform engineers has been there forever, right? Every organization today deploying any kind of code needs to have some sort of platform, right? So let's not talk about that, but let's just get what the platform engineer in Choreo would do. They would get into Choreo, help to configure Choreo as a platform for your organization need. A bank may need certain guardrails versus a healthcare might need different guardrails, right? That's where the platform engineer comes in, set it up, and that becomes, while we call it Choreo, that becomes your internal developer platform. That then brings the developers onto the platform, start building their business use cases that you need to take to your internal customers or the external customers. We glue them together. So Choreo in the middle becomes your internal developer platform. But you can't do this without abstracting some of the complexity. Software has always been abstracting complexity at different layers. Long time ago, we coded in assembler and then became the high-level languages. And on top of high-level languages, things evolved, Kubernetes came in, a lot of abstractions got built in, right? So in Choreo, what we try to help you with is how do you organize as a software engineer when you're actually trying to do distributed microservices architecture, how do you organize things, right? Yes, you can ignore all that. You can still bring your monolith and run it in Choreo happily, no issue. But it actually gives you what we call shift down, or some people call it shift left, the best practices that you start with. So we have this concept in Choreo, organization, which is like the highest level. We have also recently added sub-organizations when you're a very, very large organizations where you need to distribute things into different sub-organizations. And obviously, under every org or sub-org, you will have projects where you group. It could be finance project, it could be HR projects, marketing projects, IT projects, etc. Then within Choreo, the unique stuff is your microservice or your integration or your API is a component. Those are kind of like Choreo terminology. But these are like the very high-level concept for you to organize things from a software engineering perspective. And then these can be attached to one or many, what we call a data plane, runtime, where your workloads will run. Right? And this can be on fully managed Choreo data planes, what we call the cloud data planes, or it can be a private data plane anywhere in the world. In fact, we actually now have private data planes in WSO2 data center as well. And then the next concept is you obviously need environments. You're not taking anything from coding directly into production. You need multiple environments. Some may say, I only want 3 environments. Some may say, I want 20 environments, depending on your organization need. And that's kind of organizing it. And then I put this other one on the right-hand side just to give you how we thought about how do you actually secure them also, not just like grouping them, but how do you actually secure? For example, I know the one on the screen is not very, very clear, but if you look at it, these services within this project boundary, or what we call a cell boundary, is inherently secure. So unless you go explicitly say this particular service can talk to my other project or to an external party, it will stay secure. And even when you do that, project A, service A, can talk to the project B, service 2, right? So that kind of level of thinking that has gone into developing this platform. I didn't put this to scare you all, but just to put things in perspective, a lot of thoughts has gone into building this platform. A lot of open source projects that we have taken on. There was a lot of talk about open source earlier on. And contribute back some of it. We have taken, for example, KEDA didn't have a HTTP scale to 0 option. Our team took the challenge. They built it. They're contributing back. Similar to some of the other projects as well. But as you can see, like if you are building, not saying you can't, you can build, but just imagine the effort that needs to go in to do this. So your developers are actually become very productive, self-serviceable. They don't have to wait for 3 days, 3 months to get their environment up and going to do the development, right? Last night I was chatting to Sanjeeva and you were saying like how, I can't mention the name of the company, but that company was taking like 9 months back then to get the infrastructure environments ready to do that, right? Obviously things have moved on now, but even when you're on AWS, there is the DevOps team, there is the SRE team, so you still have to pass tickets to get things done, to get things going, right? So to put things into perspective once again, under the hood, these are some of the open source projects that we have inherited and built the platform so you don't have to think about it. And we maintain as a project. Sometimes get questions, what happens in one of those open source projects? There are issues. Obviously, we work very closely with them. And if there are bugs we can fix, we will fix and contribute back as well. Right? So if you're doing that, I'm not saying you can't. Please consider that and manage it as a product. So what does this mean from a platform engineer's perspective? Is the screen clear for you guys, by the way? Though? It's like very blurry for me. Is it okay? From a platform engineering perspective, there are so many things that we bring together. So once again, the cognitive load from the platform engineering is lifted, right? Nowadays, a lot of the companies aren't just going with one cloud. They may have on-prem. They may have a cloud of their preference. Typically, like for example, in Australia, if you're a bank, you must be on 2 clouds. You cannot be on a single cloud, right? For redundancy, availability, and other reasons, regulations, is you have to be on 2 clouds at least minimum, right? So if you have a platform engineering single team, how do you manage that across, right? Those kind of capabilities we have built into Choreo. Right? And then obviously, your engineers who are building the awesome digital experience now self-capable of doing things their own. Yes, obviously there might be in a situation they still have to raise certain tickets, right? In a big release pipeline, you don't just go, just put everything into production, right? Having said that, taking it from the code to development and to integration test environments becomes so much easier. A quote from Gartner. So just summarizing what we just talked about, the IDPs, or the internal developer platforms, abstract the complexity of the underlying infrastructure. Now, what we have done is we can have abstracted most of the major clouds, plus even on-prem, right? So if you're doing this, you don't have to really think about how am I going to put the Kubernetes in, how am I going to put all these other software in. We have done that, right? And moving on to say this not only just abstract the complexity of this, the infrastructure, but it also delivers amount of value to the customers in a consistent way. You heard yesterday, Kenny was talking about their organization is about 250,000 engineers, and they all have opinions. So if you actually let them do all that, Wipro would be like a chaotic place, right? So you have to bring some good guardrails, golden paths into the system so you can actually consistently do that in a reliably, repeatably way, right? And obviously, I think the Gartner forgot to mention securely as well, right? I put the link in there, so they do actually talk about Choreo in their report as well. So let's just talk a little bit about the impact that we have had since we gone GA about 3 years ago. A large wealth management company in the US, they were doing a lot of stuff manually, tickets back and forth with the SRE and development team. This is not a number that we came up with. This is what their CIO and the head of engineering said. 40% reduction in the time to deploy. Now they don't even think about like raising tickets, etc., because the guardrails are put in so they can quickly get deployed and promote to production. University of Edinburgh. If you were in the Barcelona conference, the video is publicly available as well. They talk about how they actually save, still continued running on AWS, but how they manage to save with Choreo. Right? I have a slide which I'll talk a little bit about it. And then home automation and an industrial automation IoT company, their biggest challenge was fast time to recover. Right? They don't need to think about the underlying infrastructure, how it is built, etc. Their biggest problem was if something going wrong, how am I going to get this fixed faster? And this number again from them, they managed to drive 5x time faster than before. Some customer statistics. Obviously, we have, these are users that have organically come through Choreo and sign up, include the enterprise users as well. Close to about 30,000 components that get deployed to date, and 450K deployment. That means some companies have gone from doing like a single deployment a month to a very, very large number of deployments. That doesn't mean that every deployment has to go to production, but even to get into dev or staging is also a massive effort, right? So Choreo has helped them to go that fast. Now let me quickly go over some of the Choreo's new capabilities and updates. We have lots. I have summarized into only a few slides, but our team is here. If you do want to get more details, please do ask. For platform engineers, we have listened. So Choreo has its own CI/CD pipeline. But customers said, how about okay, you guys have brought in best practices, but my organization has certain other things we want to incorporate. So that's what customizable CI means. Again, non-proprietary coding. Whatever you do, whatever you change, you can still maintain even if you decouple from Choreo. Right? advanced automation. They said, okay, you have some database services, some cachings, Kafka, all that as managed services out of the box. But what about other services that when we go into a cloud? This example is running a script to create S3 bucket in their project or in their organization. Yes, you can bring those Terraform or Pulumi or Ansible or whatever the scripts that you want to run. Choreo would provide the pipeline and also the debuggability capability as well, right? So what that means now, we are allowing you to extend the platform, right? This is why I mentioned earlier, this is becoming one of your platforms, right? Yes, it's powered by Choreo. Later on, we might even have the opportunity for you to customize it. Looks like, your own company's, XYZ company's dashboard. And one-click PDP, so private data planes. This is, once again, a big challenge for a lot of the organizations that you have to write Terraform scripts or Pulumi script or whatever, infrastructure as code. But if you all have read a lot of the stuff, infrastructure as code is becoming like a hell, right, for a lot of the teams without deep understanding of the clouds, right? What we have done to date, we have enabled 2 clouds, Vultr and Azure. If you go into Choreo, you'll be able to say single click, say I want this size, get it deployed. You don't even have to worry about the code. Once again, nothing proprietary behind the scene. If you want to carry on with it, yes, you can. You can take that code also and modify it if you want to in the advanced pipeline, if that's so you wish to. I did briefly mention sub-organization. Large organizations like Wipro or PLDT, et cetera, that you would want to have multiple business units for billing reasons, separation of duties, et cetera. So not just having one organization is actually helpful for them. So we have listened once again. We have added this feature is also becoming GA in a couple of weeks. Obviously, I can't not go without talking about AI capabilities. So we announced this for the cloud data plane, the cost optimization, or FinOps, we call it, for the cloud data plane back in March for Barcelona. Now we are enabling it even the cloud providers. What that means is if you're running on AWS, Azure, or any other cloud providers, we will be able to understand how your workloads are running, how much is it costing, and make recommendations. Not just saying that you're over-provisioning, but there could be reasons where you're under-provisioning, which means your services are crashing, which is not good for your customers, right? So cost optimization, people think it's about reduction. It's actually not about just reduction. It's also about how do you effectively manage and get the best business outcome for the money you're spending. Right? I'm going to play a quick video, but while the video is coming up, so this is a new feature that we have added into Choreo. Okay, it will come up. Technical glitch, guys, some reason. Yeah. So what's happening here is the user is typing saying, I want to invite a new user, right? And Choreo will go and show you where to go, how to get it. Obviously, this is the first step. In the future, you could tell the agent to say, just go invite the user. This is the name of the user, right? So this kind of agentic approach, we're adding that. So even project managers, for example, if you want to do that, they can just do a conversational thing. In this case, asking where can I find the latencies for this product, this particular component, right? Conversational, right? Next, we have added what we call the Chief AI Architect. There are multiple versions of this Chief AI Architect. The first one we are releasing is the Compliance Officer. Now, the Compliance Officer comes in 2 ways. One is we have adapted the best practices and telling you this particular API, so the services you run should work like this, but there are variations and there are anomalies, so we can actually list you and show you. First step. Second would be alerting and saying, can I go and fix this for you or make suggestions, right? Later on, we will also be adding more capability in terms of security, etc. This is the first release of that, the AI Compliance Officer. Next, which is the coolest thing, this is where, can you hold the video for 1 second? So, yeah. This is where a lot of talk about vibe coding, right? You will probably have heard about things like Lovable, Repel, Manners, Cloud Code, where you can actually go give the vibes and go build something. But building something, yes, those coding has made it super simple today, but is it ready to be deployed in a production grade? Right? What that means is, can it go and connect to an API gateway to do all the authentication authorization needed? Can it connect to a database securely? What about the logs, observability that you need to manage in production, right? So these tools are really great today. I use it every day, day in and out, for MVPs. What we have done is taken that to the next level. So you can now, within Choreo, once you have actually built that app, you can say, go, deploy this app. It will go figure out these have services that need to be connected and secured via API gateways, and it needs to enable logging so you can see what's happening underneath, all that, right? So I'm going to get that video now going. Can you? Yeah. So this is an app. What it's trying to do is scan a menu, or it could be in different languages, etc., and it will go and produce. I think you can put the languages as well, if I understood. You can select your language. It will go generate the website for you, which will show you, here is your menu, here's a photo of the menu, etc. So this whole thing now, a single command, single vibe. I don't know whether you saw it earlier, saying that take that menu app, go deploy it in Choreo. It needs to have connection to the OpenAI, etc. Now it's going and figuring all that one out, and the app is ready. Now, the difference is this can be done with other tooling as an MVP, but behind the scene, it's connecting to all the infrastructure in Choreo, right? So it's production ready. Right? This video is showing that the capabilities of that app. Important part is actually not the capabilities of that app. Important part is how do you actually manage, maintain beyond that initial deployment. Thank you. So leveraging our partnerships, so I talked about the cloud partnership, what we have. So Choreo is available through marketplace of these cloud providers, AWS, GCP, and Azure. What does that mean for you? So if you all have very large commitments or even smaller commitments with the cloud providers, you can now procure Choreo and most of our other products as well through the marketplace. That means you don't have to go get extra budgets, etc. You're purchasing from that. And not only that, if you talk to us and if you want to run POCs, we could also talk to the cloud providers and say, give credits on top of what you already have to run your POC. So it actually doesn't burn the credits that you already have. Right? And the billing and procurement become a single bill. So AWS or GCP will bill you. Right? Another cool announcement, SUSE, one of EQT family members. Most of you all know SUSE is very open source, very similar to WSO2. They acquired Rancher a couple of years ago, which manages the Kubernetes infrastructure. We have enabled and certified Choreo to run on that environment. So if you are running infrastructure on-prem, still want to sweat that asset, what that means is utilizing SUSE, Rancher, and Choreo, you can have your IDP, be it on-prem or in the public cloud. This also means that you can still continue to leverage your capacity. Most of you all have gone to the cloud. You know how expensive it can be. So it doesn't mean that you have to jump the ship and just go straight into the cloud, right? This also means that you are now consolidating your ways of managing application on Kubernetes environments. Right? And it gives you an IDP that can run on-prem as well as in public clouds. Customers and our partners and our sales team in Europe said, we want a dedicated region in Europe. We did have a dedicated data plane in Europe, but they said, no, your metadata is still in the US. Right? So we created 1st of July, I think it went live, no one? Yeah? 1st of July, since 1st of July, we have a dedicated region in Ireland. So all of the European customers can now use this region without even having to send the metadata to our US control plane. What this means is both the control plane and the data plane sits in Europe. So if your partners, companies are concerned about data regulations or entity, et cetera, you can now utilize the European region. Obviously, the reduced latency, there's not a significant latency difference, but still, if you are concerned that there will be some latency, if you're using the CDP and your data center happens to be in Europe, it's better to have something very close, right? So you reduce that as well. Staying with WSO2's open source philosophy, we are continuing Choreo as open Choreo into open source. And Samira will talk a little bit later about more about the open Choreo and etc. But this is like we are now gearing up to donate open Choreo to the CNCF Foundation. That means not just WSO2, there will be other contributors. What this means is, just like our other software and other products, you'll be able to run, take, download, run open Choreo, contribute, and then if you do decide, like our other software, I know there was a panel earlier saying they've been using our software for like 7 years and now deciding that they want some support. Yes, this is exactly what we are doing as well. And we will continue to do that. And not only that, I think Samira also wanted me to mention that going forward, Choreo will also run on open Choreo, right? So we are going to, kind of like drink our own champagne. I won't say eat our own dog food, but drink our own champagne, right? So that's actually an exciting project. We announced this in Barcelona. The latest version is 0.3. Again, Samira will talk a lot about it as well. Yeah. And I believe that is my last slide.
All right. Thanks, Kanchana. And good morning once again, all of you. And thank you for being here for this session. So, I'm going to talk about the principles of a good internal developer platform. So just to be clear, this is not about capabilities. It's going to be about principles. So the structure of the presentation is such that I'm going to start off with defining why you need an IDP really, right? Trying to explain the purpose behind it. And then going to be talking about, okay, what it should be providing and whom it should be providing those. And then we are going to talk about, okay, how do you really extract a set of principles to build an IDP or to build an IDP yourselves or to buy an IDP from somebody else. So that's going to be the structure of the presentation, and I'm going to be talking about 10 key principles that I think are important to have in an IDP. So that's going to be what I'm going to be talking about. So just to get started off with, so why do you need an internal developer platform? Why would anyone need an internal developer platform, right? So to explain this, I decided to use an analogy of a city, a planned city versus an unplanned city. So what's an unplanned city? An unplanned city is a place where you let anyone build anything they want, wherever they want, whenever they want, however they want it, right? So you have people building different kinds of houses, schools, hospitals, clinics, and all of these things all together, right? Wherever they want, whenever they want. And what is the outcome of this, right? It's obviously chaos, right? Because you might have now factories within residential areas, right? Hospitals within factory areas. And to get something done, it takes a long time, right? Because this is not optimized. You have to go all over the place. There's a lot of wastage in commute, A lot of wastage because things are not organized, right? And a lot of possibly health hazards, security hazards, all because you just allow anyone to do anything they want, however they want, wherever they want, right? And obviously it looks ugly from the outset as well, right? Because there's no order, there's no consistency, so it looks ugly on the outset as well. But compare that to a planned city. A planned city is a place where everything is organized. You have your neighborhoods, residential areas, urban areas, schools, government administration offices. They are clearly demarcated, right? So this is a place where everything is organized, right? If you heard about this project that the Saudis are doing these days, creating this thing called the line, right? Where they are basically setting up a straight line of infrastructure in the middle of a desert, and they are basically bringing in everything into it, right? And their promise is, so houses, schools, malls, everything into it, right? And their promise is, to get something done, it's going to be, your maximum commute is going to be 20 minutes, right? So if you want to get to a school, it's going to be 20 minutes max, right? If you want to get to a hospital, it's going to take 20 minutes max. The reason why you can achieve that is because everything is organized and put in order, clearly thought of, right? You don't get that with an unplanned city. Now apply that to the enterprise, right? So this is the same situation we have in the enterprise. All of us are in organizations. We have many different teams, many different developers developing many different kinds of applications. Imagine what will happen if you let anybody in your teams build whatever they want, however they want, whenever they want, wherever they want, right? You'll end up with absolute chaos. You'll end up with applications that don't have consistent interfaces. You'll end up with different teams learning and relearning the same things over and over again, lots of inconsistencies. You'll have different teams purchasing different kinds of tools to solve the same problem, and every team solving the same problem and not sharing that information with each other. So that is what you end up with, without a proper order, right? So this is what an IDP is supposed to solve. It's supposed to bring order to this chaos, right? It's supposed to give you consistent interfaces, share what you have from the other teams, have consistent processes, use the same set of tools. So this way, you don't waste a lot of time. You deliver faster. You don't learn and relearn the same things that 3 or 4 of your other teams have already done within the organization. You end up building applications that look consistent. They don't look ugly on the outset anymore, because now everyone is building consistent, right? So this is basically the why behind an internal developer platform, right? So this is why you need an IDP in an organization, right? To bring order to that chaos. So what should an IDP deliver, and to whom should it deliver these values to, right? Again, to explain this, I thought of reusing the same analogy. Now, if you think of a city has it has its citizens, and it has its city planners and utility operators. Who are these citizens and the residents? The citizens and the residents, they are the ones who build things in the city. They are the ones who build the houses, the schools, the hospitals, and all of these things. They are like our developers. They build the applications, right? These people who build these things, they don't build the infrastructure. They don't figure out, how do I get electricity? They don't figure out, how do I get water? They don't figure out, how do I deal with my sewage system and all of that. They rely on those systems given to them by the city council, right? So this is like these citizens are basically just like our developers. They are building applications, right? They are building services, business objects, data entities, different kinds of things. They don't build the underlying infrastructure. They rely on it from the platform, right? So this is one category of people that an IDP should be catering to, right? And the next category, obviously, are these city planners and utility operators. They don't build the houses. They don't build schools, right? But they build the electricity infrastructure. They build the plumbing system, the water lines, right? All of these things, zoning rules. They are the ones who provide that infrastructure. And these are like our platform engineers and operators, right? They don't really build the applications, but they provide the underlying infrastructure that these application developers need. So this is basically the landscape of what an IDP should be providing, right? These utilities that you need, and who they should be catering to. Basically, the developers and also the operators as well. So you may have heard about IDPs before, and you see a lot of talk about IDPs being for developers. But really, it is also for platform engineers as well, right? And we'll get into the details as we go along. So it's not just the developers, but also for platform engineers too. And so if you want to really think of, okay, what are the principles, or like going beyond the principles even, what are the capabilities this should have? One critical thing to understand is, getting this right is all about understanding that this is about abstractions. It is all about understanding that this is all about getting your abstractions done right. Now, if you think of a city again, you see 4 layers of abstractions, 4 different layers of abstractions. The first one is about domains. So this is like the city's neighborhoods, right? Like I mentioned before, it has residential areas, it has school zones, it has urban areas, and these kinds of things. So an enterprise is like the same. Any business is like the same. You may have your financial space, your financial systems operating. You may have like sales and marketing, right? You may have other areas of abstractions. So getting these abstractions right is key to building or understanding the principles of an internal developer platform. And going beyond the neighborhoods now you get into the actual business. So what is the actual business? These are basically the houses and the shops and hospitals and these kinds of functionality. In an enterprise, these are basically your APIs, your web applications, your jobs that you're building, data entities and things like that, right? So this is the other area of abstractions that is important to get right, right? Any enterprise won't allow, just because you build web applications, right? You shouldn't have the freedom to pick any kind of technology with any kind of framework and so on, right? It needs to be abstracted out, clearly guardrailed, so that whatever you're building becomes consistent, right? Aligns with the rest of the organization, right? So getting those abstractions right for those business functions is also critically important. So that's like the second bucket of abstractions to get right. The third one is about deployment, right? So apply this analogy to a city. Now, you may have your neighborhoods, you may have your houses and schools and everything, but they'll still not be running. Because in order to run these systems, you need the electricity, you need the water lines, you need the sewage systems, you need the laws, right? So these are the things that are actually needed for running the system now. So this is another area of abstractions to get right. Apply this to your enterprise. This is basically your CI/CD pipelines, your infrastructure automation layers, right? This is what are the things that are needed to run those systems. And finally, the fourth is about middleware. So you may have all these things, neighborhoods, house, you may have the things that electricity and all of these things, but you need to get these things connected together, right? You need to get them connected and talking to each other in a controlled and a governed manner. So this is all about the middleware. This is about your gateways, your firewalls, your ingress controllers, egress controllers, and all of these things. Getting them connected together in a consistent and an architecturally proper way. So this is the fourth kind of abstractions to get right. So these are the kinds of abstractions that you have to think about when deciding on the principles of an IDP. So next we'll talk about what are these principles that get derived or emerge out of these abstractions, right? So there are 10 of them I'm going to be talking about today. The first one is about separation of concerns. So this actually has 2 parts to it. The first one is about separation of concerns, understanding that there are developers and operators that an IDP should be catering to, right? These are 2 very different kinds of people, right? The things they do, their interests and goals are very different, right? If you think of a developer, come as a developer to a platform. If I'm a developer, what are my interests? My interests are to build my applications. My interests are to build my APIs, my jobs, and all of these things. But as an operator, that's none of my business. As an operator, my interests are to provide the connectivity, to provide the infrastructure, to make sure the scaling is done right. So these are my interests. So when deciding an IDP, it's very important to understand that this should be catering to both of these audiences. The functionalities that you need for these 2 kinds of people are very different. The abstractions you need for these 2 kinds of people are very different, right? Now think of a developer, for example. Now, when I write a piece of code, I run it on my laptop or somewhere, I run the test, it seems to be working fine, I push my code to JIT, and now it has to get into production. Do I, as a developer, really care whether this is running on a container or on a VM or as a serverless function and so on. For the most part, no. Right? I have a piece of code, it's functional, I push it. Now it has to run on production. So that part is not really relevant for me. So if it's not really relevant, the platform should hide it away from me. It should abstract it out, right? Because I don't care, right? So that's one aspect of the developer. But now put the operator hat on. Does the operator need to know whether this is running on a VM or on a container or on a serverless function? Absolutely yes, right? Because without knowing that, you cannot operate it, you cannot scale it, right? So from an operator point of view, it shouldn't abstract the information out. It should expose it so that these operators can work with it, right? And this, another example is about the programming language. Now, if I'm a developer writing something, do I care about the language and the technology? Of course I have to care, right? Because without that, I cannot develop my code, right? So I need to know what the build script is, I need to know what other libraries are, all of those things I need to know. So that should not be abstracted away from me in the platform, right? Because as I'm a developer, it should be exposed to me. But think of an operator. To an operator, everything is a workload. Whether this is a Java workload or a Go workload or a C# workload, the operator doesn't care. It's a workload, right? So it's okay to abstract that part out from the operators. So understanding this separation of concern is critically important in an IDP. And the second part of the separation of concern is understanding that there is a control layer and then there is a runtime layer. The control plane and data plane, as Kanchana was also referring to several times, right? So the control layer is where all your signaling instructions are issued from, right? But your actual runtimes can be very diverse, right? You can have different environments on different kinds of infrastructures. You can have your development in your local data center. You can have your production systems on a cloud, right? So these are very diverse. You could have one workload running on a VM, another workload running as a container. They can all be very diverse. You can have different environments on different clouds, right? So all of these are, the diversity that the runtime offers, right? But across all of these diversity, you need one consistent control plane so that you get one interface to control everything behind the scenes. So understanding this separation is critically important for an IDP, right? So that's like the second part of it. And the third one is about enterprise portal. So believe it or not, many organizations that I deal with don't really know everything they have in their organization. You go as a developer into an organization, try to build something, you're trying to find some kind of service like the order processing service or something. The answer is, I know a guy who knows a guy who probably knows another guy where the order processing service is. That's the reality on the ground, right? I was talking to some customer yesterday, and they don't know how many services they have. They don't know what services they have. That's the reality. So another key principle in an IDP is to give that discoverability, that visibility into the organization. So that's one key aspect of a portal. But that's not the only thing, right? So just because you discover, that's not sufficient. An IDP should also make it easy to connect and consume those services. Just discovering is not sufficient. Simplify that process, make sure it aligns with your organization's policies and so on. So getting that part is also critically important. And not only for consumption, like I said, but also for creating stuff. So you may have heard about golden paths and things like that for developers, right? So these are also critically important. So this portal has to be used as the entry point for getting stuff into the system as well, not just discovering stuff within the system, right? So it should create these paths, these governed ways for developers to put stuff, contribute stuff back into the system. So that's another aspect of it. And a third aspect of this portal is the governance, right? Just because I have a golden path, to deploy my Java service, doesn't mean I get it, with the best standards possible, right? You need to put in the relevant governance policies to make sure that there are no security loopholes, it aligns with the organizational best practices, the industry best practices, and so on. So this portal aspect should consider not just discoverability of course, consumption, the golden paths, and also the governance rules so that whatever you put into the system is consistent and aligns with everything else in the organization. So that's like the second principle. The third one is domain-driven design, right? So since we have been talking about a city, right? Like I said, cities have neighborhoods, residential, urban, government administration offices, school zones, and so on. All of these neighborhoods, they have their personalities. They have their rules of operations. They are not the same. They change from place to place, from neighborhood to neighborhood. An organization should be the same, right? So if you do not have these zones or neighborhoods, when you're building something, you may end up building things in the wrong place, right? So this is the same with the enterprise. Unless you have these domains clearly identified and demarcated, right? Unless an IDP gives you that, developers are going to create stuff in places that they don't belong. And the result of it is, as we discussed in the beginning, is utter chaos, right? So lots of IDPs ignore this fact completely, right? They just focus on reducing cognitive load, giving golden paths to developers, and speeding the delivery. What's the point of speeding the delivery if what you're going to create at the end of the day is chaos, right? It's like having a fast car and driving towards a cliff. If you're driving towards a cliff, you might as well have a slow car, right? If you're in the business of creating chaos, you might do it slowly. What's the point of doing it fast so that you have time to adjust and fix it, right? So this is the importance of this principle of getting these domains right so that developers, when they're contributing stuff, they don't end up creating chaos at the end of the day, right? So that's the importance of that particular principle and why an IDP should facilitate that. The fourth one is about having an API-first mindset in the IDP. Now, when I say API first, I don't mean REST APIs and Open APIs and GraphQL and so on. This is about having an API-first mindset. And what does that mean? So you create different things in your platform. Services, web applications, jobs, databases, caches, queues, and all of those things. Having an API-first mindset means understanding that this is going to be used not just by me, but by many other folks, right? It's going to be shared. It's going to be reused. And therefore, you have to treat everything, the IDP has to treat everything as a contract, right? As a product. It needs versioning. It needs revisioning, right? It needs proper deprecation policies, right? It needs proper lifecycle management. If things are no longer adding value to it, it should be taken off. Otherwise, it ends up becoming garbage in the system. So an IDP, while it enables golden paths and all of these things, should enforce an API-first mindset for everything that is being created on it. Otherwise, at the end of the day, you end up creating a lot of garbage and nobody, again, knows what's in the system. And it also ties into the portal aspect of it because having an API-first mindset also means that things have to be discoverable. So that's a sub-part of it as well, right? So this is the fourth principle, having an API-first mindset, right, within the IDP. The fifth one is about, similarly, having a security-first mindset, right? So this is, of course, an important aspect too. Now, when you are living in a city, people, the citizens, they want to feel safe. They want to feel protected, right? So security has to be built into the system from day one. You don't feel safe and protected if you have lots of security guards, lots of checkpoints, checking your bags everywhere you go, having lots of military on the roads, right? Okay. It may sound secure, but you don't get that sense of security in that kind of an ecosystem. What you get is anxiety, right? So, and the reason for this is because security is not built in. It's added as a patchwork, right? That's why you get all of these gateways, all of these checkpoints, right? But if it is built into the system, the citizens can feel safe. And therefore, when you apply this to the enterprise, when developers contribute their stuff into the platform, they feel safe, they feel protected. So thinking about security, or the security has various dimensions to it. If you think of applications, authentication, authorization, for services, you think about data that is stored on disk. You need to think about how safe and secure they are. Are they properly encrypted, especially the sensitive information? Then data that is moving along between workloads, are they properly encrypted? So there are various aspects to this security. Role-based access control, who can do what, right? So all of these things have to be built in. If you bring it as an add-on or as a patchwork, you get that same feeling as if there are too many security guards, too many military personnel, and so on, right? That's a false sense of security, right? So, and of course, the benefits are that developers and operators who are running this system, they feel safe and secure. So that's like the fifth principle, having a security-first mindset in the IDP. The sixth one is about a universal interface. I can't count the number of IDPs that are out there that claim to be IDPs, but they're just a collection of tools put together with a script, right? This is not an IDP. That's basically a set of tools put together, right? IDP stands for Internal Developer Platform. I wish it stood for Integrated Developer Platform, right? Because there are so many tools out there that claim to be an IDP that are just a collection of, Argo CD with some Grafana and some Prometheus OpenSearch, and you stitch it all together and call it an IDP. That's not a true IDP, right? As we discussed in the beginning, it's supposed to elevate the experience of the operators. It's supposed to elevate the experience of the developers. You don't get that elevation by putting a set of tools together. It's like this vehicle diagnostic tool, right? So you have this vehicle diagnostic tool, you plug it into the OBD port of your car, and you get all the diagnostics in one interface, right? All the data from the sensors, the other parts from the system, tire pressure, heat of the engine, everything in one interface. Now imagine if you are given 20 different tools to get this information from. One for checking tire pressure, one for checking the heat, right? So that's basically these systems that are put together. It's not integrated. It's not one interface. You have to use different tools for different jobs, right? One tool for deployment, another tool for logs, another tool for analytics, and so on, right? And therefore, having a universal interface across all of these systems is critically important. Otherwise, you don't get that elevated experience for your operators and the developers. So that's like principle number 6. Principle number 7 is self-service. So this is again a very common thing in IDPs. If you read about IDPs, you'll see this written 100% everywhere. It's about self-service, right? But so this is basically, so why this is important is when a developer wants to get something done, they shouldn't now be really in the business of creating tickets, calling the SRE team, and so on, right? So they should have the freedom and flexibility to get something done, things done themselves, right? So you do something, it gets automatically created. You get the logs, it automatically comes to you in your interface, and so on, right? So this is about self-service. But what tends to get ignored is that these operators, they also need self-service. It's not just the developers, right? Think of the operators providing utility facilities to a city. They need consistency. They need guardrails, right? You can't be giving 110 volts to one part of the city and 220 volts to another part of the city, right? You can't be given different water pressures to different parts of the city. It needs to be consistent. So they need self-service capabilities for the IAC rules that code that they may be writing, for when dealing with the sensitive information, they need the proper guardrails, right? When doing risky actions, they need the proper guardrails. Otherwise, you just end up doing these repeated, boring things every single day, writing Terraform code, Pulumi, or whatever over and over again, right? So so not just the developers, the operators too, they need self-service from the platform, from the IDP, right? So that's principle number 7. Principle number 8 is about becoming ops-driven, declarative, and automated. Now, obviously, to get this elevated experience, everyone understand that automation is critical. Everything has to be automated all the way down, right? But automation without discipline is just utter chaos, right? So that's the importance of becoming ops-driven and declarative. So what does ops-driven mean? Ops-driven basically means, adhering to the GitOps-like workflows, right? Every change you make being recorded, right? Every change you make being audited, every change you make becoming reversible. That's what ops-driven means, right? Automation without ops-driven is just a recipe for disaster, right? And it's the same with becoming declarative. Having things in declarative form is critically important. Now imagine city operators, right? Now, for example, in a city, you need to turn on the street lamps in the evening when the sun goes down, and you have to turn them back on in the morning, right? Now imagine having to do this thing manually. It's not convenient, right? It's cumbersome. And if something goes wrong in the night and the switch goes off, you now have to come in and turn it back on again. But imagine a system where you can declare the desired state, where you can say, as long as there is darkness, the lights have to be on, right? And the system automatically reconciles the switches to that desired state. That way, you get a hands-off experience of the system, right? When the sun goes down, the lights immediately come up, right? If something goes on in the night, You don't have to get up and turn the switch back on. Again, the system reconciles it into that state. Same thing in the morning. The sun comes up, the lights go off, right? So this is the importance of having a declarative nature in your IDP. Things have to be ops-driven, declarative, and automated, right? Principle number 9 is obviously intelligence and insights. So this is another critical area that of importance for IDPs, right? So IDPs are not just pipelines and dashboards, right? They need to be like smart cities, not just allowing traffic to flow, but analyzing that traffic, optimizing it to get the best benefit out of it, right? Preventing accidents, right? And whenever there's some collision, rerouting things through a different path, right? So this is why intelligence and insights are critically important to an IDP. Otherwise, it's just like a city with scripts, right? So when it comes to insights, an IDP needs to serve different kinds of people. For developers and operators, it should provide enough insights for troubleshooting and fixing issues soon. For business stakeholders, it should give them visibility about whether they are getting the expected value out of their assets, right? To engineering managers, it should tell them whether they are delivering optimally and efficiently enough, right? And again, delivering fast is useless if you're breaking the system, right? So if an engineering manager just looks at a report, said, wow, great, we've released 35 times this week, that's great from a delivery point of view, but if it's creating bad customer experiences, if on the other side you're getting bad customer reviews, then this is not really great, right? You should slow down and improve on the quality. So this is why these integrated insights and intelligence is important, right? Otherwise, it's just some reports that you look at, right? So intelligence, of course, is not just for insights, but across the board for efficient modes of operating. Now, Kanchana showed a small demo where intelligence is used for actual development and deployment, right? So intelligence is across the board, not just for insights, right? So being intelligent and insightful is another key principle of IDPs, especially in the world we are operating today. The final principle, The final principle I want to leave you with is treating an IDP as a product. So I've seen this mistake done many times. IDPs are treated as projects, but that's not a good situation to be in, because software delivery never ends, right? You deliver software every day, and it never ends. But the ways in which you deliver software changes. The kind of software you deliver changes. Your workflows changes, right? But software delivery never changes. A project is something you start and finish, right? So an IDP cannot be a project. If it becomes a project, you take it today, you build it, you finish it, and you produce something that is good enough for today's situation, right? Today's state of the world. Come tomorrow, everything's changed, right? Your workflows have changed. The type of software you have to deliver has changed, right? So that is why treating your IDP as a product is critically important. And what does that mean? That means it needs to have a clear vision and a roadmap. It needs to have regular release cycles. It needs to have proper life cycle management on your features, right? Incrementally improve your features, garbage clean the features that are not adding any more value. So it needs a product mindset, right? Not a project mindset, right? And non-technical aspects of it, such as adoption. Having a good capability, while necessary, is not a sufficient factor for the success of any product. It could be working great, but if people are not aware of it, if people are not adopting it, it's still a failure, right? So that is why treating the IDP as a product is critically important, right? Not just the functionality, getting it adopted, getting awareness is critically important. And of course, continuous adaptation. Today it might be serving VMs, tomorrow containers, serverless, and who knows what next, right? AI workflows and all of these things. So continuous adaptation is important. So that is why it's important to treat it as a product. So that brings me to the end of my presentation. So these are the 10 key principles we talked about. So I think it's when thinking of the principles or capabilities of an IDP, you have to understand why you need it. You have to understand what it should give, to whom it should give it. You have to understand that it's all about the abstractions, getting the abstractions right, and then these are some of the 10 principles that I thought are critically important to get a good IDP.
All right. Thanks, Kanchana, for the introduction. I'm Tishan. I'm heading the engineering work for Choreo product. And then I'm also passionate about the developer experience side of the platform. So that is what we are going to talk about today. So the topic, how internal developer platforms enable developer self-service. What is internal developer platform? Nuwan explained in great detail in the earlier session. So to explain the topic, let's go to the boring definition of what is developer self-service. So I took this from the Puppet blog. Developer self-service describes automated tools and processes to empower developers to work without help. The part I want to highlight is empower developers to work without help. That is where we should target with developer self-service. With that in mind, I'm picking up, I'm giving a different definition for that. We have been talking for a long time, so to keep things interesting, developers are architects, creators, magicians, or like Jedi who create these digital experiences for your customers, right? And developer self-service in a parallel universe is like giving them the force, giving them the ability to go and create these digital experiences by themselves, from provisioning environments, resources, to deploying and also getting the logs of the production environment as well. So that is an alternative explanation to what developer self-service. And then with that, I'm going to use this scenario for us to move forward. So in these days in Sri Lanka, there's a huge push for private banking offerings. Anyone in the audience from Sri Lankan banking sector? All right. Yeah, you know what I'm talking about. So there's a great push these days for private banking offerings. So I'm going to pick that scenario. So we have we are modeling two banks. They want to offer these private banking offerings, and so they have the need to go to market first to capture the limited prospects. Not everyone would get selected for a private banking offering, and in this case, we are using two developer profiles, Arakin and Luca, representing two banks tasked to develop an API to return existing high net relationship clients. Yes, I know the names. My marketing team asked me to change it, so I changed it to Arakin and Luca. Net relationship criteria is, in this example, the sum of investment account balance and the lending account balance. If you have higher than this amount, you are eligible for the private banking offering. And I throw in another requirement, they have to need to persist the monthly report as well. So this is the scenario that we are going to move forward to the rest of the presentation. So with this scenario in mind, a very high level L1 kind of architecture that you can come up with. You have your net relationship balance service, the new one that you are going to implement. And then you need two dependencies to get your lending balance and your investment balance, and then a DB to persist your monthly report. A very simple L1 architecture for the sake of argument. And then let's look at how these two developers are going to go forward with that. So we are going to follow their developer journey, touching upon four key principles of four key capabilities of developer self-service. So first one is dependency discovery. So dependency discovery is basically now the Arakin and Luca needs to figure out where to get that investment account balance and the lending account balance. So Arakin, the developer profile is, he's coming from a legacy mega bank with a proven but aging platform with a lot of red tape and processes. And Luca is coming from a more agile, newer bank which employs the internal developer platform. Those are the two developer profiles. In a parallel universe, Arakin is this megalithic empire using his imperial engineers to get the things done. Luca using his self-serviceable RTD2 droid to get things done. So those are the two synonyms. So what can Arakin do to get the dependency discovery done? I'll list few options. First one is ask around, as Nuwan said earlier. You go and talk to that engineer who has been in the company for 15 plus years, like Aziz over there, and say, how can I get these two resources done? And then another thing is you go ahead and search in a source code in a component that is likely to do the same thing that you are doing. get the dependency done from there. Or else, if you are a more structured company, you have your internal documentation somewhere, you go search and there, get it. And then another step forward is using heterogeneous portals. Like you will have a proper API manager deployment, then you would be having API descriptions over there which you can go through and search, or cloud provider portals. Each and every option of these will get the thing done. It's offering some kind of a developer self-service. But we will look at how internal developer platforms are redefining this developer self-service. So on Luca's side now, in internal developer platforms, the vendors and even the self-built one offer this service catalog. So service catalog is a collection of all the services and resources that is being offered and deployed within your organization that you can freely use. That is a catalog of that. And in internal developer platform implementations, these catalogs will have automated dependency additions. That means if you deploy a new service within your organization, that would appear in your service catalog so that others can see that. And they would have searching and filtering capabilities, a proper searching and filtering rather than you going through the text. And they would be context aware. If you are searching from within one project or a domain, it would show you the resources and services available in that domain for you. And it would also give you developer tool integration. You don't have to look into go into some console and look at this. It will be integrated into your VS Code or your favorite idea for you to search as well. So these are some capabilities offered by internal developer platforms to make the argument more solid. We are using Choreo as the reference implementation of an internal developer platform. And I'm going to show you examples from Choreo how that service catalog dependency discovery is done. So this is a screenshot. It's pretty blurry for me, but what this is our service catalog. We named it as the internal developer platform. In this area, you have the services that are available for you to consume. And then you can have multiple services available there. You have services, database, and multiple resources there. You have the filtering capabilities over here, and you will have searching capabilities over there. So you can search and filter your resources. And in this case, Luca will come and find the investment banking backend over there. And once he dives inside that, they can go and also check the API definition and see whether that dependency suits the need of his development. Once that is done, the platform will offer a capability to connect to that service as well. Give it a name and a meta concept of connection where you can say, I want to connect it at this level, organization level, or from the public internet, and I want to use this security mechanisms. And then after the connection, the platform itself will give you your service URL and the API key for you to use, and information on the other side in a way integrated that you can give this meta tag in your source code, where a platform will now inject your service URL and the API keys as environment variable, so that you don't even have to copy paste. So this is one reference architecture implementation from Choreo. Different internal developer platforms will choose to do this in different way. The point to take home is it's all integrated in a self-serviceable way. Now with that capability, now our architecture diagram is looking like this. You have your get lending balance and get investment balance services figured out now. To support that in a self-serviceable way, in a very conceptual manner, you at least need these components where you have your CD pipeline which deploys these services, but also publish them into a service catalog. That service catalog service will keep the definition of the services in a DB and offer that to your developer portal, which will give you the searching and connecting capabilities. So that is how our architecture diagram is evolving. From here, we will look at the advantages of providing this kind of dependency discovery. So you have now ready-to-use information, your service URLs, API keys, and everything, and less cross-team interaction. You don't have to go ahead and find the guy or girl and ask for the URLs, you have configuration governance, because now the system is providing you the URLs and everything that you need to connect. How to feed that system is governed. It's not a Confluent doc or a Google Docs that somebody has written. It's governed. And because there's no copy pasting, less human errors. With this, we are moving on to the next step. Now the dependencies are figured out. Now you need to figure out the database, provisioning. So next up is provisioning. In Arakin's case, I'm going to make 3 simple options. You send a approval email. I want this database. Can you please approve? And then your DevOps or SRE platform engineering team get to the database. Or you have implemented a ticketing system. You submit your ticket, wait for them a day, half a day, 3 days, and you get your database done. Or in some cases, your developers have been empowered to write your own IAC, infrastructure as code. You write it, you have the pipelines, run it, you run it, get the database. In all the cases, again, you get the database, but timelines differ, the experience differ. How does usually internal developer platforms, a properly developed one, does this? You would have UI, CLI-based provisioning options, a wizard for you to click and get your resources provisioned, or even source code-based provisioning options where in your source code itself, in a meta file, in some notation, say, I am depending on a database of this type, and by the time your source code is getting deployed, it will provision the required resources on the environment as well. And usually these provisioning options that the internal developer platforms offer will support different resources and then classes in that as well. So if you take database as a resource, and then it will support Postgres, MySQL, and things like that. So with this, again, we'll look at a concrete implementation of this through Choreo. So Choreo offers you to create database servers within the UI itself. And then once this is created, it will get added to the earlier the service catalog, internal developer portal that I talked about, so that others can discover that as well. And on top of that, private beta that we are introducing is Kanchana talked about these pipelines, where infrastructure pipelines, where your platform engineering team can define some pipelines developers can use, have it available as templates, and then which developers can use themselves without writing the IAC themselves to provision their resources as well. And again, another example from that same one, Kanchana use provisioning S3 bucket flow. So in this way, now developers are empowered to get their resources provisioned. With this, let's look at our architecture diagram again. You have your databases figured out now. To give that self-serviceable experiences, now you have to have some more things in the other side. From your developer portal, you need some kind of a IAC composer. That is, you get the... Excuse me, can I get the slides? So from your developer portal, thanks. You get the parameters, and your IAC composer will compose the proper IAC IAC file that is getting needed. Some templating it can be the value sample that it is composing. And then it gives you to IAC runner like Argo workflow or something to run it, and then provision your database, and also add it to the service catalog service for observability. Again, very conceptual architecture. More details, Lakmal will talk about it in the session in details, how we have done that. And we can talk about it after the session as well. We are available, but I'm putting it here to give you a very high-level idea of what it takes to develop that. To the advantages slides now. With this provisioning now, you have no wait time. You can provision it yourself. Infrastructure is now governed. It is provisioned by developers, but through a control system. So it is governed. How much memory, how much disk, where the disk is provisioned, everything is governed. So organizations can govern that. And the pipelines are now commonly tested. Developers are not writing this and that pipelines. It is a set of pipelines that they can use, everyone is using. So there's less room for error in the pipelines as well. So now at this point, we have figured out the dependencies. We have figured out the database provisioning as well. Now the developer has to, Arakin and Luca, go ahead and implement their API. Now it's about deploying that in the system. That is where golden paths or paved roads, as Gartner called them, comes in. So this is where how easy it is for you to create a repo, put the code there, and get it up and running in the production comes in. How this happens in the Arakin's traditional legacy enterprises, you clone and copy from old repo, remove the files, put your new source code there, and get it up and running. It happens. It happens. I have seen that happen. Or you copy and paste from some other repo, your Docker files, pipeline YAMLs, find and replace, get it working. You trial and error CI/CD configuration, infrastructure provisioning configurations, get it running. Or else in a more structured organization, you would have internal documentation on how to get this done. How you create a new repository, this is the structure, this is a sample Docker file. In some way, again, Arakin side, you can do it yourself, but there are frictions. And internal developed platforms, on the other hand, do things in a different way. They would give you create component wizards, either through UI or in some cases through CLI as well. This would govern the repo structures. This would govern the IAC pipelines that you need to create your pods, your Kubernetes services, and whatnot that you need to deploy your service. This would govern the CI/CD configurations, how you are going to configure your GitHub Actions or your Argo. And this would also govern how your observability hooks are configured as well. Apart from the experience that the developer gets, because this process is governed, the base images you are using now in the world of Kubernetes are now verified, given by the system. So that part of governance comes into the picture as well. And also, when you create from this flow, your services will now get registered in the service catalog automatically as well. So that is how it is happening in the enterprise of Luca with the internal developer platform. Again, we'll look at implementation from Choreo side. So in Choreo, you have different component types that you can create. Services, web applications, tasks, webhooks, even MCP servers. A template that we provide for your organization so that you can go ahead and use that. Once you choose one of those, you get this wizard. And through the wizard, you can give your source repo. You can choose what the language it is. Once done, platform will take over. By default, CI/CD will be configured for you. You can customize that, of course. CI will then go ahead and try to build your code, right? And push that into a container registry or build artifact repository. Once CI part is done, platform will also offer the CD part, where you get your build artifact from the registry, and then you will have the chance to deploy that into multiple environments. How many environments you have, what are the workflows or rules that you have to deploy, that all can be configured other hand from the platform engineering team. But platform offers, from developers' point of view, they're just CI/CD is offered to them. With that now, we will look at our architecture diagram again. Now you have your net relationship balance deployed, right? To get that deployed in a proper developer self-service way, now you need some more components. You need some kind of a configuration orchestration service which is connected to your developer portal to get the configurations like the repo URL, the language, and create the configurations that are needed for your CI and CD systems. And that configuration orchestration service will now configure your CI and CD. Your CI will be configured to connect to your source repo, get it, build it in some way. You might be using Argo or GitHub Actions internally, and then you have to push it to some kind of a build artifact registry. In the world of Kubernetes, that would be a container registry that you are using. And from there, you would configure your CD system to pull from your artifact registry, and then to deploy to your environment, involve Kubernetes to the Kubernetes cluster. So this is the updated architecture diagram after we have deployed the net relationship balance service. So up to this point, we have covered, this is the third key capability of developer self-service. With this, when we move into advantages, now developers have to do less tasks, no writing of ISCs, organizational guidelines enforcement, because everything is running through these pipelines or wizards. You will have secure runtimes because we choose the base images. Battle tested configurations for your CI, CD, or whatnot system, other system that you need. You'd have, connected with the secure runtime, you'd have stable base images as well, because you are choosing your base images now. And default sanity checks that the organization can configure, like Trivi, Sona, whatnot. So these are the advantages that you have. So we are now talked about dependency discovery, provisioning, now golden paths. The last capability that I want to highlight is built-in observability. So now everything is deployed. Now the next thing upon mind of the developer is basically maintainability. How to maintain that? To maintain, you of course need observability. You need your logs, matrices, and traces to be working perfectly. To do that in Arakin's enterprise of a megalithic empire or the legacy bank, right? You would have to configure your observability manually, get the files, configure your Fluent bit, configure your Prometheus, whatnot, or you'd have to add sidecars to collect the matrices and publish somewhere. That is configuration part. And then about the weaving part, usually you would have to use secondary portals for you to log in and look at the logs, matrices, or traces. Or even in some cases, if you are to look at a production metrics or production level logs, you'd have to open tickets, wait for your SRE or platform engineering team to give you those tickets as well. That is how it is done in Arakin's enterprise. In Lucas' internal developer platform world, the observability will be auto-wired. So auto-wired means there will be no or minimal configs to get your observability working. Because the platform is made and you are using golden paths to create your workloads, golden path will ensure that your observability is auto-wired. You would usually get unified dashboards, a single place to look at all the three pillars of observability, and then also will get built-in alerts for you as well. One other thing some internal developer platforms or the designed ones offer is seamless correlation between different systems. So a deployment will have different components, load balancer, API gateway, and your actual workload that is running. When you want to maintain, when you want to debug something, you need to correlate between log traces of each and every one of them. So that correlation is also important. So those are some things that internal developer platforms will focus on providing. Again, customer will look at to a concrete implementation using Choreo. So this is Choreo's project level observability view. So in this, now in the same investment banking operation, so this, I don't know whether you can see, this is the new API that Luca developed for the high net worth relationship balance. It is connecting to the investment banking backend and the lending banking backend over there. That is the project architecture that is shown in the observability view by default. It is not drawn, it is drawn automatically by the system. You can see the project level logs, and then you can drill down into the component level, which will show you things like request latency, CPU usage, memory usage, and of course the logs. So these are built into the platform based on different implementations of the internal developer platform. The views and the DX will be different. I'll throw in one other thing other than observability, which is insights. So Choreo offers several insight factors as well. In this case, I would get a screenshot of the operational insights for a CIO kind of a profile. Now you can see how many projects you have, how many components you have, what is the organizational level deployments happening, memory usage happening, things like that. There are a lot of other insights that will be available by platforms like this, right? And with this, we'll move on to our final piece of the architecture diagram. Again, very conceptual. I have boiled down everything into an observability collector representing both metrics, logs, and traces. I know it's not the case practically, but for the illustration purposes. So you have a collector, you need some kind of a processor to process and keep it, and then you have an API which offers this data to your developer portal. Or in some cases, your developer portal implementation might choose to go ahead and directly talk to your observability processor as well. That can be done as well. So this is how our final architecture looks like. While we have done our business requirement here in yellow and orange color, the gray color ones are the supporting system that we had to have this self-service developer capabilities. With this, we'll move on to the advantages section. Now you have quick feedback cycles because you have the metrics available for you. You have inbuilt alerting, which can alert you of SLA violations and things like that. And you can do quicker issue resolutions because you have the observability configured for you from day one. Now let's look at these 3 pillars of advantages. I made them in 3 pillars in purpose. So the first column, ready-to-use information, less cross-team interaction, no wait time, less tasks, quick feedback cycles, all boils down to velocity and efficiency. Saeed from Vitality Group talked about this one, and then Kenny from Wipro also talked about this one, how they have improved their velocity by developer platform. Saeed, when asked about what's the best innovation that he had done, he said, it's the investment on the mobile delivery platform that we have done, which has increased our efficiencies by 40%. That's what the self-serviceable internal developer platforms do. They will increase your efficiency and velocity. On the second column, you have configuration governance, infrastructure governance, organizational guideline enforcement, secure runtimes, inbuilt alerting of SLA violations. All this boils down to inbuilt governance and security that the internal developer platforms with proper self-serviceable capabilities offer. Third column, less human error, common tested pipelines, battle tested configurations, stable base images, default sanity checks, and quicker issue resolutions. All boils down to stability. So these are the 3 advantages I picked which a proper self-serviceable internal developer platform will offer to you. Why these 3 advantages are very significant? These 3 advantages, or I would say properties of your organization, will help you to make your organization performing at an elite level. To connect the dots, this is Dora metrics. It's a part of Google now from 2018, and they published these 4 metrics, and then they categorize organization on like elite, great, good, like in categories based on the score that you get. So each of these matrices, so deployment frequency is a measure of your velocity. Lead time for change is a measure of your efficiency. Change failure rate is a measurement of stability, and mean time to recovery is a measure of efficiency and monitoring. If you look at our 3 pillars back, it covers most of these things. So if you are having a proper self-serviceable internal developer platform, even from Dora metric standards, your organization will automatically be in the elite level of performance or efficiency. One more factor to support that, this is actual data from Gartner's Why and How Developer Experience Drives Outcomes. They conducted research with a set of developers, and from those numbers, what they came up with, I want you to focus on left and right-hand side, is 31% more efficiency. These high-quality developer experiences, I read that as good self-service experiences, most likely to improve delivery flow, and 33% more likely to attain their targeted business outcomes, which is quality equals to stability as well. Another proof that our 3 pillars are important 3 pillars that organization, enterprises should focus on. With that, I'm going to coast into the closing remarks. This is from Gartner Hype Cycle Platform Engineering 2025, just released. Treat the developer experience like a product. Assign clear accountability for delivering end-to-end developer journey to dedicated developer experience team and product owner. while enabling individual development teams to identify and address local developer experience needs. I wanted to focus on the fact that product and dedicated developer experience teams and having product owners. That is the mindset that we should have when thinking about internal developer platforms. You can buy it, you can build it. If you're buying, there's a team behind that who is taking care of that. So you have to just compare the feature set of different vendors, get your buying decision done. If you are trying to build it, you have to make sure that you have a dedicated team, a product owner who is treating it like a product, right? That is the only takeaway I want you to take from this 30 minutes.